Okay, next, can we interpret a stem and leaf diagram? So we have a stem and leaf diagram in front of us. Can we pull out each of these statistics from there? So let's quickly go through them. Firstly, the mode. That's going to be the most popular or the most frequently occurring piece of data. We're going to look into the body of the diagram itself. The digit 7 appears twice, 6 appears 3 times, and 8 appears 3 times as well. Don't be bamboozled by this 8. One of them represents the number 628, and the other 2 represent the number 638. So 638 is represented twice in this diagram. However, 646, that is represented 3 times, and we're looking down here to recognize that. So the mode for this particular stem and leaf diagram is not the number 6, it is the number 646. All right, so the mode in this case, okay. I should have put a key on here for you, so we're all sure exactly what these numbers represent. Okay, so we managed to find the mode. Let's go ahead and find the median. Okay, so using what we've seen before, I want to use the position formula to locate where I should look for the median. Firstly, how many pieces of data are there? 14 pieces of data. So that's 15 divided by 2. I'm looking for the 7.5th piece of data. My answer is not 7.5, but that is where I'm going to find my answer, the 7.5th piece of data. So as we go through these leaves, we're looking for the 7.5th. All right, well, this is the 7th and this is the 8th. As I said before, if I'm looking for the 7.5th, I need to go right in the middle of the 7th and the 8th. The 7th is 632, the 8th is 638. If you're not sure how to find the middle of these numbers, we're actually finding the mean. So we're going to add them together and divide by 2. So I'll get 632 plus 638, all divided by 2, and that's going to give us our answer. Personally, I look at the number 2 and 8, and I know in the middle of 2 and 8 is 5. So my mean of these two numbers, my median value for this stem and leaf diagram should be 635. Okay, question 3 is the mean. This should largely be a calculator job. We're going to add each of those values and divide by 14. I should be putting it into X bar. It's the sum of all the data points divided by the count, which in this case is 8869 divided by 14, which gives me 633.5, 633.5. Just a quick sense check. Does it make sense? If I got an answer of 700, straight away alarm bells will be ringing. It should never be that high. Okay. Interestingly, the median and the mean are actually quite close to each other. So once again, that's a little quick confidence boost that we're getting these values correct. Okay, next moving on to the interquartile range. So bringing together a few of the things that we've looked at already. The interquartile range, I'm going to need the upper quartile and the lower quartile. The position formula for the upper quartile and the position formula for the lower quartile. Okay, so the lower quartile, also known as Q1, I'm going to find that position with n plus 1 divided by 4, which in this case is going to be 14 plus 1 divided by 4. Okay, and that's telling me the 3.75th position. Okay, so that's where I'm going to look, 3.75th position. All right, be really careful here. I want to go exactly in the middle of the 3rd and 4th. Okay, some people try and figure out how do I get a little bit closer to the 4th than the 3rd. For discrete data like this, it's unnecessary to do that. We are actually just going to go bang in the middle of the 3rd and the 4th value. All right, so the 3rd and the 4th value are here. So we're thinking of 622 and 623. Out of those, we can see that the quartile should be 622.5. So my lower quartile, 622.5. Similar thing for the upper quartile. It's 3 times n plus 1 divided by 4. I already know what n plus 1 divided by 4 is. Let me just multiply that by 3. And that tells me I'm looking for the 11.25th piece of data. So let me quickly just grab those. Where are they? 11.25th. And we're looking at these two values here. Okay, so the mean or the middle of 644 and 646 is going to be 645. Okay, great. So we've got our upper quartile and we've got our lower quartile. Together, we can use that to identify the interquartile range. Interquartile range is going to equal the upper quartile minus the lower quartile. Q3 minus Q1. In this particular case, 645 minus 622.5. And the interquartile range is 22.5, just what we're looking for. Okay, so just a point on that. So this means the middle 50% of data has a range of 22.5.